Okay, so here's today's phase diagram worksheet. We've got it opened up in Cami. You could open it up in DocHub or whatever is your favorite write on a PDF sort of software. The first part is basically just defining what we did on Friday. I'm going to give you about a minute or two to go ahead and just read this to refresh your memory. Okay, so I'm going to pause the recording and you guys read that for about 2 minutes. All right, so let's go ahead and look at the phase diagram and kind of review what you should have just read. So the melting and freezing point, anything on this line is both solid and liquid, but on one side it's solid, on the other side it's liquid. So that melting point, it depends on how the temperature is changing, if it's melting or if it's freezing. Okay. Same with sublimation and deposition. And then vaporization and condensation between the liquid and the gas. You are going to have on your test, you're going to have a blank one of these diagrams, and you're going to have to label solid, liquid, gas. So what part of the graph is actually the solid part, the liquid part, and the gas part? You also need to make sure that you know that pressure is on the y-axis and temperature is on the x-axis. That's really important for these graphs, and they're always set up the same way. The critical point, we watched a pretty neat video on the Friday before spring break that talked about supercritical fluids and how that's how they decaffeinate coffee now, is by using those supercritical fluids. And that is one of those things that is indistinguishable between gas or liquid. So it's kind of a different thing. Some books will say it's both solid or it's both gas and liquid. Some will say it's neither one. But at any rate, there's too much energy for that gas to go back to a full liquid at that critical point. So we want to make sure that you can label the critical point on a graph and the triple point. The triple point right here is where all three phases can exist. So it's going to be kind of melty, gaseous, solid, all at the same time. Okay. Let's go ahead and go through some of the questions. We're going to be referring to this diagram. So like, as you can see, it is not labeled solid, liquid, and gas. You might want to put that on there for your own reference. Okay. So I'm going to go ahead and type just for my own reference. You will need to be able to label those from a blank diagram as well. And I am going to zoom this in just a little bit so we can get a bigger graph. Okay. So let's read our first question. What are the values for temperature and pressure at standard temperature and pressure? That question, it says you're going to look at this graph, but we should know that from earlier discussion. So we know that standard temperature is 0 degrees Celsius or 273 degrees Kelvin. But for our graph, we have degrees Celsius. So we know that this is standard temperature. Okay. And then for pressure, standard pressure, we have atmospheres as our label. So we're going to put that in atmospheres here. That is 1 atm. So we could go ahead and circle that 1 atm because we're going to be asked questions about standard pressure here. Okay, so we could go ahead and label it standard pressure. Okay. All right. So then, what is the normal freezing point of this substance? So in this question, you have to kind of ask yourself, all right, what is freezing? Freezing is when something goes from a liquid to a solid. Okay. So I find the liquid part of the graph and the solid part. I know it's going to be on this line. Well, there are several temperatures on this line. So I need to find the temperature that correlates with normal or standard. So standard pressure right here at 1, if I come right straight down from this line, from this point, come right straight down, I'm going to find 100 degrees Celsius. Okay, so then I'll just come here and I can type in 100 degrees Celsius. Okay. All right, so give me a thumbs up if you kind of understand how this graph reading works and you're good. Okay. All right. So for boiling point and melting point, go ahead and answer those 2 questions. I'll give you about a minute, and then I'll help you with these ones, and we'll send you on your way. Okay, so go ahead and answer 3 and 4 and make sure you understand those. All right, so to kind of look at those questions that we just had, what is the normal boiling point of the substance? Boiling point is from liquid to gas, so at that standard pressure, we're going to say between liquid and gas and come straight down, it's about 325. Give me a thumbs up if you got that answer right. Okay, so we're doing pretty good with that. Then the normal melting point of the substance is 100 degrees. You could reason because freezing and melting are equal and opposite sort of things. But you could also say between the solid and going from liquid to solid at normal pressure is 100 degrees. So reading the graph or using your reasoning skills. All right, I'm going to go through just a couple more, and then I'll let you do some on your own. So what is the phase, solid, liquid, or gas of a substance at 2 atmospheres and 100 degrees Celsius? So in these questions, you're just going to find them and report what you see. So at 2 atmospheres and 100 degrees Celsius, you're going to say, all right, here's 2 atmospheres. And I'm going to come across to 100 degrees Celsius is right here. So the phase is a solid because we're in this region of the graph. So let's go ahead and we would just write, you can just put an S if you want, or you can write out the whole word. I do not care which one you do, but it's up to you. So that is how you're going to do 5, 6, 7, 8, 9, and 10. All right, go ahead and do 5, 6, 7, 8, 9, and 10. And I'll give you about a couple of minutes, and then we'll come back together and think about some of these other questions. Okay, let's look at number 11. What is the condition of the triple point of the substance? Well, look at the graph, and then what is triple point? If we come back up to this example, the triple point is exactly where there's that fork in the road, where you have 2 lines coming from 1. So go ahead and read their graph. And if that's your triple point, what temperature and pressure are you going to have? Temperature, pressure. Okay. So make sure that you put in values at number 11 for those. I'll give you a second to type those. And then number 12 says, if a quantity of this substance was at an initial pressure of 1.25 atmospheres and a temperature of 300 degrees Celsius was lowered to a pressure of 0.25 atmospheres, what phase transition would occur? Okay, so for these questions like this, and you have several of them, the first thing you have to do is find where does it start. So I go back to the graph, 1.25 atmospheres, and I'm going to kind of draw this on there. 1.25 atmospheres is right here, and a temperature of 300 degrees Celsius, that's right here. So if I connect those, my number 12, okay, that's where I start for number 12. And then was lowered to a pressure of 0.25 atmospheres, what phase change would occur? If I lower this to 0.25, then I'm going to go from a liquid to a gas. Okay, so that's vaporization. Okay, we want to use vaporization because it's not really evaporation. Evaporation just happens as a process throughout the day. But vaporization, we have changed something. We have vaporized this liquid. So for number 12, we would write vaporization. Okay. Wait, I wrote that on the wrong one. So when you're using Cami and you put it the wrong place, you just pick it up and put it where it belongs. All right, so go ahead and let's set up 13. And you're going to do the same thing for 13, 14, 15. And then 16 is very similar. These next problems are very similar. But you're going to find a temperature. So let's go ahead and set up 13. If a quantity of the substance was an initial pressure of 1.25 atmospheres, so we're at the same pressure, and a temperature of 0 degrees Celsius, and lowered. So we're lowering to the same place, but we're starting at a different temperature. So we're going to start at the same pressure. Okay. I think that's what it said. Yeah. But we are starting at 0 degrees. So 13 would be here. 13. And I am going to lower it to here. Am I going through the same phase change? No. Because in 12, we were in liquid and we went to gas. In 13, we're in solid and we're going to gas. Do you know the word for that? Solid to gas? It is sublimation. Okay, so sublimation is solid to gas. Deposition is gas to solid. So sublimation, solid to gas. So that's what we would type for 13 is sublimation. Oops, we need our text box. Okay. All right, so go ahead and do 14 and 15. I'll give you a couple minutes to do that. So for 14 and 15, you will want to go up and find what are the right words for going in those directions. Huh? For 14 and 15 that you just were doing on your own, you want to find the right words. We're going to finish the worksheet, and then you'll submit it today. All right. And I'm just going to go through 16 and 17 with you, and then you guys will do the rest on your own and submit. So 16, if this substance was at a, yeah, we have time to do that. If this substance was at a pressure of 2 atmospheres, what temperature would it melt? All right, so let's process that one. I'm going to change my color so we can see a little better. If this substance was at a pressure of 2 atmospheres, at what temperature would it melt? So 2 atmospheres right here. And I'm just going to continue my line because we're going to stay at a constant pressure for 16. At what temperature would it melt? Well, we know that melting is going from a solid to a liquid, so we're going to be right here, and we drop straight down halfway between. It's going to be about 180, 190. You have a guesstimate, right? Or maybe you 200. Some guess right there, or draw a straight line. That would be ideal. Then you're going to have the right answer because we know between solid and liquid is melting. So about, can we go straight down? We could probably go ahead and just put 200 on 16. So okay. I feel like that is probably easy enough for you guys. What do you think? Do you need me to go through 17 with you? No? I can't see thumbs, so I don't know. Yes is up and no is down. Do you need me to get going through them? Yes? Okay. All right, let's go ahead and we'll look at 17 then. We're still at that 2.0 atmospheres of temperature, or at pressure, 2.0 atmospheres of pressure, and we're still looking for temperature. So what temperature would it boil? So we're still right here. We could go ahead and say 16 and 17 right there. But this time, instead of saying melting, we're saying boiling. And if we go back to our reference graph, wait, I said the wrong word. Melting and freezing are at the same temperature. So what were we asked here? We were asked if the substance is at a pressure of 2.0 atmospheres, at what temperature would it boil? We can see that the critical point is at like 850, almost 850 degrees. So at such a high pressure, we are past the critical point. So we could go ahead and say at 850 degrees, okay? Because once you're past the critical point, it's going to be that supercritical fluid that is either not gas or nor liquid, or both gas and liquid. So we are past that point. All right, that was probably too high of a pressure to be able to really do that very effectively. So then when we look at the next set of questions, we're just at 0.75 atmospheres, and we're still going to look at melt and boil. So we're looking for a melting and boiling point. So when we look, we'll find, let's get a different color. 0.75 right here, a terrible line, but it is 18 and 19. So then we can really clearly see. Melting is between solid and liquid. Okay, so that's this temperature right here. And boiling is between liquid and gas. So we'd just be a little higher temperature right here. There's not a long time that there's not a big range of temperatures for this substance to be a liquid. Not a big range of temperatures there. Right. All right, so I want you to try to answer the rest of the questions on the paper yourself. Hopefully going through the graph kind of brought back some of the things we did before spring break. But I will leave this up on the screen for you to be able to reference. Make sure that as you go through the document, as you go through the other questions there are, you refer to your reference points, your reference graph. So like I said, I will leave that on the screen for you guys to finish that. But I do want you to finish this document and submit it as a PDF to today's assignment.